Okay, we probably won't get through all of this in this video segment. I think we'll probably get through graphing solutions. So we're just going to start learning how to get things onto the graph other than just points. First of all, we need some definitions. A linear equation in two variables can be written as ax plus by equals c. If you remember several lectures ago, we talked about linear equations in one variable. So if you look back at your notes there, you might remember what to look for. Now obviously a linear equation in two variables is going to have two variables, so that's the easy part. How do we know whether it's linear or not? If you remember linear equation in one variable, the thing we looked for about whether or not it was linear is if the variables had any exponents on them. So as long as there are no exponents on variables, and no variables in denominators, which you probably won't encounter for quite a long time, we know we have a linear equation. Okay, solutions. For a linear equation in one variable, how did we solve it? Let's say we had 2x minus 7 is equal to 1. Well, we'd add 7 to both sides. We want to get x by itself. We get 2x equals 8. Divide both sides by 2. We get x equals 4. That's my answer, and I'm done. Now, for a linear equation in two variables, the solution's a little bit different. Let's look at x minus y is equal to negative 1. And rather than solving this by going through steps to solve it, I just want you to think for a minute. Think of some values for x and y that would make this true. Okay, we'll just list all of the things we can think of. Well, we know that maybe if we put 2 in for x and 3 in for y, 2 minus 3 equals negative 1, so that would work. But is that the only values for x and y that will work? Well, no, we could do like 5 minus 6, that would give me negative 1. Or 10 minus 11, that would give me negative 1. We could even throw something in a little different, like 0 minus 1 would give me negative 1. Let's just plot those. We know x goes left and right, y goes up and down. So if we go over 2 up 3, that gives me that point right there. Over 5 up 6, over 10 up 11, over 0 up 1. Now what do you notice about all those purple points? Kind of make up a line, don't they? Now, we don't necessarily just have to use these nice little perfect numbers. What if we tried 2.5 and 3.5? 2.5 minus 3.5 is still negative 1. So we could fill in all the little dots on that line. Every single point on that line will make this equation true. So if you have a linear equation with one variable, the answer is just a number. That's the example we did at the top of the slide where x equals 4. But if I have a linear equation in two variables, the answer is every single point on that line. So one way to represent all solutions to that equation is to graph the line. So let's check to see whether or not these points are solutions to this equation. How did we check things when we just had one variable? We plugged it in to see if it was true. So now that we have two variables, we just have two things to plug in. So how do we verify? We'll plug this point in and see if the equation is true. For the first point, we'll put in negative 5 for x and negative 4 for y. So we put negative 5 in x's spot, negative 4 in y's spot. When we're plugging in, it's usually best to put in parentheses. It helps us remember that we're multiplying. 4 times negative 5 is negative 20. 5 times negative 4 is negative 20. If I add those together, I don't get 20, so that's not a solution. That point is not on the graph of that line. Okay, let's try the next point. 0, 4. Putting in 0 for x, 4 for y. Put in parentheses for the variables, and then put my numbers inside. So I have 0 plus 20. Well, that's 20. 20 equals 20, so that is a solution. That point is on the graph of that line. Okay, so let's see how we go about graphing these lines. This method is not my favorite method, but it is in your book and it's in every math book that I've seen, so it's important that you know how to do it. I think the next example is a little more helpful, but let me just do this one first since you do have to do some this way. So graph by filling in a table. If I know x is 1, I want to find out what y is. If I know y is 4, I want to know what x is. If I know x is negative 1, I need to find out y, and if I know that y is 2/3, I need to find out x. So for the first point, if I know x is 1, I put 1 in for x. 5 times 1 is just 5. So I have 5 plus 3y equals 12. Now I need to solve for y. So I subtract 5 from both sides. If I subtract 5 from the left, I end up with 3y. I subtract 5 from the right, and I end up with 7. I get 3y equals 7. To solve for y, I divide both sides by 3, and I get y is equal to 7/3. It's not a very nice number, but that's okay. We can still deal with it. I'll show you how to deal with it in just a minute. Just leave it for now. Okay, I need to find x. I know that y is 4. So I put 4 in place of the y. 3 times 4 is 12. So I have 5x plus 12. Again, the 12 came because I put in 4 for y and I got 3 times 4. 12 on the other side was there before. To solve for x, I subtract 12 from both sides and I get 5x equals 0. I'm not putting quite as many steps in as I did a few weeks ago. You should be pros at solving equations by now. Okay, now I don't have x by itself yet. What do I need to do? Okay, I need to divide both sides by 5. 0 divided by 5 is just 0. Don't get scared of 0. It's fine. 0 on the top is fine. 0 on the bottom of a fraction is where you have problems. Okay, putting in -1 for x. What will 5x become if I put in -1 for x? Okay, I'll have -5 plus 3y equals 12. Add 5 to both sides, I get 3y equals 17. Divide both sides by 3, and y is equal to 17/3. Now do this fourth one on your own. Pause the video and come back when you've got it done. All right, so now that you've got it, 5x plus 3y, but y is 2/3, is equal to 12. What happens when I take 3 times 2/3? Okay, the 3's cancel, so I have 5x plus 2 equals 12. Subtract 2 from both sides, and I get 5x equals 10. Divide both sides by 5, and I get x is equal to 2. So now I have these 4 points, and I should know how to graph them. So for the point 1, 7/3, since 1 is in the x spot, I go over 1. But what on earth do I do with 7/3? This is a point where 7/3 would be a lot easier to deal with if it was a mixed number. So it would be 2 1/3. You could equivalently just take 7 divided by 3 on your calculator and get 2.33333. That just tells you to go up 2 and a little bit of the box. So we'll go over 1, up 2 and a bit, and we get our blue point right there. For the point 0,4, where is that? Over 0, up 4. If you put that point at 4 on the x-axis, that's a common mistake, but make sure you see why it really belongs on the y-axis. I go over 0. X is my left-right number. 4 is my y number. That tells me how far up and down to go. So I go over 0, up 4. Now for the next point, 17/3. Most people don't just know in their heads where that is on the number line. So think of it as 5 2/3, or put it on your calculator. 17 divided by 3 is 5.66666. So we go back 1, up 5, and a little more than half. And we're right there, over 2 and up 2/3, so a little more than halfway up that box. Now, do those points look like they're in a line? Yeah, they do. Now, if you've made a little mistake, and little mistakes are easy to make, if you've made a little mistake, you might have a point out of line. That's one reason I like giving you 4 points, is it makes it really easy to see who the real points are and where the mistake is. So if you have a mistake, please don't draw a curved line. Please go back and figure out what the real numbers are, so that you do have a straight line. And there's our straight line. Now this last example is the way that I think is a lot more helpful. Let me just give you a hint. If you aren't given values in your table, it makes your life actually a lot easier because you get to choose the values yourself. I strongly, strongly, strongly recommend you do something first. I've got 3 hints on this problem. Hint number 1, solve for y first. I promise it will make your life easier. Just get in the habit. It really does save you work. So if I want to get y by itself, I need to subtract 2x from both sides. That would give me -5y equals -2x plus 10. For those of you that thought that you'd have 10 minus 2x on the other side, it's very logical to think that, but I promise your life will be easier come lecture 11 if you'll get used to putting your variable first. So even though 10 minus 2x is correct, -2x plus 10 will help you in the long run. Okay, next I need to divide both sides by -5. So on the left, -5y divided by -5 is just y. That's easy. Now on the right, again, there's a couple ways you could do this. Just trust me on this, that this will make your life easier. Do it a term at a time. So we'd have -2x divided by -5. That would just give me positive 2 over 5. The negatives cancel, and I'd have 2/5 x. And then 10 divided by -5. Positive 10 divided by -5, I'd have the negative 10 divided by 5 is 2. So again, I've not shown all the steps, but you should be good doing this by now. Now I'm just going to choose some values for x. I'll talk about why I chose those values in a minute, but just trust me at the beginning. So I'm going to choose, and I chose them very specifically. This is not random at all. I chose -5, 0, 5, and 10. Trust me for now, I'll explain why later. What happens when I plug those in? Okay, for the first, I'll have 2/5 times -5 minus 2. I just put that -5 in place of the x and put parentheses around it. When I plug in for values, put parentheses around it. It makes your life easier. So 2/5 times -5. Well, look, that 5 is going to cancel with the denominator. So I just have 2 times -1, or -2 minus 2. The -2 on the end stayed the same. The 2/5 times -5 became -2. And -2 minus 2 gives me -4, so I have -4 for y. Now you always want to choose 0, because 0 is by far the easiest thing you could ever plug in. 2/5 times 0 is 0 minus 2, which gives you -2. All right, if I plug in 5, my 5's cancel, and I have 2 minus 2, which is 0. And if I plug in 10, 5 goes into 10 2 times. 2 times 2 is 4. 4 minus 2 is 2. Let's put these on the graph. Should be old hat by now, and connect the dots. Now I want to talk to you about the second hints. Why did I pick the values I did for x? Like I told you, it was not random. I picked those very, very specifically. If you've got a fraction in front of x, and most likely you will, choose the denominator and multiples of the denominator, because that way when you plug it in, it just makes the math so much easier. It kills my fractions. Because if I have a denominator or a multiple of the denominator in for x, those will cancel and I'll just have regular numbers left. Secondly, I also chose those numbers because they were far apart. If I choose numbers that are really close together, I'll still have correct points, but it's really hard to get an accurate line if my points are too close together. So hint 2, choose values for x that are far apart, and hint 3, choose values for x that kill the fractions. And those values are, if you've got a fraction in front of x, choose the denominator and multiples of the denominator. Okay, intercepts is where we'll pick up next time.